Hi everyone, let's look at today's Lit Code challenge question. Oh, I'm happy that it is a medium level because I'm hoping to solve it really quickly. I need to go to a firecracker party at 8, so I want to finish this within half an hour. And by the way, happy 4th of July. Let's look at this question. Oh, there are hint as well. Nice. Question 1493, longest subarray of 1's. Have I done this question before? No. Longest subarray of 1's after deleting one element. Okay. Given a binary array norms, you should delete one element from it. And return the size of the longest non-empty subarray containing only 1's in the resulting array. Return 0 if there is no such subarray. What does this mean? So it means that I can only delete one element here and return the size of the longest non-empty subarray containing only 1's in the resulting array. Okay, got it. So if I delete 0 here, then there will be, then how many subarray of continuous 1 will be there? Just 1, right? And so the answer is 3. And if I am looking at these norms, then I can delete so the subarray of 1's is 1 is this one, right? 3. So 1 subarray's length is 3 and 2 and 1. So if I delete this 0, then the answer will be, then the subarray length will be 3. If I delete this 0, then the subarray's length will be 5. So I need to I can delete one element like that. Okay, let's look at another example. Norms is equal to 111. Here I don't even need to delete anything. If I delete one element, then it will be, the answer will be 2. The constant is that norms will be at least 1, there's no empty, and norms I will be either 0 or 1. Acceptance rate is 62%. So let's see. And if it was like this, then what would be my, I can only delete one element, so it will at least be, the size will be, the size will be 3, maximum will be 3, even in this case if there are 2 zeros. Suppose there are 1 2 3 4 1's and 3 1's, and then what will be the case? So I'm looking at this one and I can see that the size is, subarray is, so there are, this is the subarray of size 1 2 3 4, and this is the subarray of size 1 2 3, and this is the subarray of size 1 2 3 4 5, and this is the subarray of size 2, and this is subarray of size 1 2 3 4, right? So just by looking at this subarray, just by looking at this array, I know that okay, there are 4 subarray of 4. So this is the answer that I got, right? And I think that what I can do is, just by going through it once, I know that this is the amount. There is 5 1's. So if I delete one number, if I delete one element, then which element should it be? Suppose if there is just 1 0 here, then my answer would be I delete this element. My answer would be 4, 5, 6, 7. Or there is 4, 5, 6, 7, or it can be 5, 6, 7, 8, or it can be 5, 6, 7, or it can be 4, 5, 6. So these are all the possible values, right? So in this question, 4, 3, 5, 2, 4. So there is 5 here, and then there is 2 here. I know that there is 0. Actually, I'm just trying to think of optimal solution. So first of all, let me think of brute force solution first. So in this case, there are 4 contiguous 4, and then there is 2 zeros, right? So I think that I should also have a maximum value here. The maximum is 4 first, and then since there are 2 zeros, I'll not add to this solve array. And then there are 1, 2, 3, 3 1's. Or you can say running sum. Running sum is 3 1's, and then this is 1 0. Since there is just 1 0, so I'll add to running sum 1, 2, 3, 4, 5. I'll add 5 here, and since there is just 1 0, so I'll add 2 here, and since there are more than 2 zeros, so I will just 5, 6, 7, 8, 9, 10. So this will be my maximum now. Running sum will start from 0 again, and then 1, 2, 3, 4. There is 4 element. Running sum is 4, and we have ended, right? So okay, I think I got an algorithm here. So my algorithm is running. So there will be running sum, and there will be maximum, and running sum will continue. So I will continue adding to running sum if there is just 1 0. So I will so what I'll do is, so continue adding to running sum if there is just 1 0 in between. If there is more than 1 zeros, then update maximum. Maximum and reset running sum to 0. Okay, so running sum is add 1 to it if value is 1. So running sum is sum of contiguous ones. So running sum means sum of contiguous ones. Running sum means sum of contiguous ones, and here I can see that because I can just delete one element in between, right? And I need the longest non-empty subarray containing only ones. So it means that I can just try to find ones, find a sub. I can just, so running sum means sum of contiguous one length of, or you can say running sum means not even sum, running length, or I'll just write sum here, but running sum means length of contiguous ones. So I'm just trying to find the length of contiguous ones. Okay, and this is maximum length. So the running length sum is not a good so this is a running length. Okay, so for here 1 2 3 4, right? Running length is 4. Maximum I will write the 4. Since there are more than 2 zeros, it means that I cannot just delete 1 0 here, right? Now I will do 1 2 3. So running length will be 3 here. Oh, okay. But you know what? I should be careful about this scenario as well. 1 1 1 0 1 0 1. So at this point I can only delete one element, right? So I cannot keep on deleting. So suppose here running length is 3 when I reach here, and when I reach here, okay, this is 0, so I'll just ignore it, and then because I can delete it, I'll consider that this is deleted. So I will keep on running. Sum is 4 now, and here what I can do is I can just keep count of zeros in counted, or actually this problem is not that simple. Like I'm saying, the logic is quite similar though. So what I was thinking is, so this is the running length 1 1 1 2 3 4. So this is 4, right? So maximum length will be 4 now, and this can be the case here. So if I delete this, if I assume that this one is deleted, then it will be 1 2 3 4. Running length will be 4. But I can also assume that this one is deleted, not that one. So at that case, yeah, this one might be the case, right? 1 1. So in this case, 1 2 3, this is my running length, and then I got 1 0. It is good because I only got 1 0, right? 1 2 3, and then this will be 1 2 3 4 5. This is 5, right? Now what I can say is past length of Subarray, and current length of Subarray. So this is 3, and this one is 1 2 3 4 5, and I encountered 0 already. So if I encounter 0, then what I should do is, I always try to do everything optimally. I was saying that this is a brute force solution, but I again started to think it in an optimal way. Just let it be brute force mind. Okay. So this one is the length is 3 here, and this length is 1 2 3 4 5 here. Since there is just 1 0 in between, so I can say that maximum length is 5 6 7 8 here, and 1 2 3 4 5 6 7 8 9 10. So pass length is 5, and current will be 10 now. Since there is just 0 in between, so I can just say that this is 15 again. Maximum length is 15. Yeah, and if there is 0 and 0 and again 1 1 1, then it will be like, since there are two zeros, so pass length will be 0 and current length is 1 to 3. So at this point there is nothing that I can add up to that. There is nothing that I can add to this 1 3, because I can only add the past element, right? And the past I can, because there are two zeros in between, so I cannot add anything. And yeah, that's it. But what about this case, 1 1 1 case? In this case also 1 2 3 4. No, I did not get any. I need to delete one element here, so yeah, also consider this case. I will consider this case, don't worry. But let me first, this is an ace case where there is no any zeros, to be deleted for deleting. You should delete one element from it. Suppose if it was 0 0 1, then also the length would be 4, right? Because I can delete 1. But if there is nothing, then I cannot delete anything. So in this case, if there is no zeros, then answer will be total length minus 1. And for this ordinary case, it will be like 1 1 1 0. Suppose 1 1, suppose it is like 1 1 1 and 0 1 1 1, then it will be 1 2 3 4 5 6. And if there is 0 again, then 0 is like a divider. I can only whatever the element after 0 is, I can only add to the last one, so that is the thing. So there will always be past and current. So if I cross 1 0, then this will be my past and this will be my current. And if there is two zeros, then after crossing two zeros, my past will be 0, because I cannot add anything to my current array. Yeah, that is my algorithm actually. So this algorithm doesn't work. So my updated algorithm is there will be pass length subarray and current length subarray, and when so pass length subarray is also equal to 0 and current length subarray also is equal to 0, and there will also be maximum. And when suppose there is 0 0, so I'll always start at 1. So whenever 0 subarray, whenever 0 is each mate, whenever 0 is made, then or I can say whenever 0th subarray is made, then it means that it's time to update max. Okay, whenever 0 subarray is made, then update max and also update pass length subarray to 0. So pass length subarray will be current length subarray, or pass length subarray will be 0 if 0 subarray length is greater than 0. Okay, so yeah, so here I can see that 1 2 3. So pass length subarray is 0 and current length subarray is now 3. Now since 0 subarray is made, so I will update pass length subarray to current length subarray, that is 3, and I will also update max. Max will be equal to pass length subarray. Max will be equal to max maximum comma pass length subarray plus current length subarray. Okay, so 1 2 3, and so this is my pass length subarray and this will be my current length subarray. So whenever I hit 0 again, then it will be like 3 plus 3, because this is my current and this is my past, so 3 plus 3 6. Okay, and I will update pass length subarray to current now. If this 0 is greater than 0, then I will update pass length to 0, and I will continue. So I encounter 0 again. It means that the current length subarray is 1 2 3 4. Pass length is 0, so the answer will be just 4 only. I mean this will be just 4 only. So if this is just 1, then I think that I need to insert 0 at the end, so that I can just I can just add the last one as well. So yeah, that's it. Let me code. I'm always in a hurry to code. So what I was thinking is, because if there is 0 0 0 in the middle, then my past and first. Okay. So I will always continue. So for constant n of norms, I think that for first of all I need to insert push 0 at last, so that I will update max at last also. And then for constant n of norms, I want to know the length, right? So length of zeros, length of ones, So I think that it will be 0 length equal to 0 and let 1 length equal to 0 and length, this will be current length of array will be 0 and let pass length of array also be equal to 0, and for let I is equal to 0, I is less than norms dot length I plus plus while norms I is equal to norms I plus 1, I guess. If norms I is equal to 1 and norms I is equal to norms I plus 1, then current length of array is equal to current length of array plus plus, right? Or what am I doing here? I'm just trying to, if norms I, if it is equal to 1, then I'm adding it to current length of array plus plus, else if it is 0, then I'm adding it to 0 length plus plus. So whenever I encounter 1, then current length will be sub plus plus and 0 length will also be I will make to 0. If 0 length is, I am doing this right, whenever 0 sub array is made, then whenever zeros sub array is made, then I'm doing this right. So it will be like update maximum is equal to method maximum past length of array plus current length sub array. So first of all, I want to go till the end of the sub array actually, yeah. So how can I do that? If norms I, if it is equal to 1, then I want to be adding, right, plus plus. What I can do is, I think while I is less than norms plus length, while I is less than norms plus norms dot length, and I can just keep on norms. If norms I equals to 1, then current plus I plus, then I plus plus. So if I do this, then I will get current length Subarray, right? If it is equal to 0, then I will get 0 length Subarray, right? Plus plus. Yeah, I think this would work. So first of all, I'll get so this will give me 1's. Suppose if it is 1 2 3, so this will give me current length Subarray is equal to 3, right? 1 2 3. So I will be here in the beginning, and then it will be here 1 2 3. Okay, now I encountered 0. So if 0 length is greater than 1, then it means that 0's Subarray encountered. So if I have encountered 0th Subarray, then what I should do is I should update maximum to maximum to method max maximum comma current length Subarray plus past length Subarray, right? Then I should also update past length Subarray. So if 0 length is greater than 0, actually if 0 length is greater than 1, it means that there are more than 1 0 in middle. So if it is greater than 1, then past length Subarray should be equal to 0. Otherwise, if it is not greater than 1, then past length Subarray should be equal to current length Subarray. Okay, and currently I should also reset current length Subarray too, so that I can reset it from the beginning, so that it can start from the beginning. So if there are more than 1 zeros in the middle, then past length Subarray will be 0. Otherwise, it will be equal to current length Subarray, and then current length Subarray will be equal. It's reset to 0. reset it to 0 for another subarray calculation. So norms I is equal to 0. While norms I equals to 0, I will keep on increasing, and I plus plus. At this point, I will be equal to 1. So at this point, I will be equal to 1, and what I can do is I will just reset here only. So it will be equal to 1. Coordinate length subarray will keep on increasing. When it is 0, and I will see it. And that's it, right? How will I know if there is how can I but how can I do it for this condition, the condition where everything is 1 1 1 1? I added my 0 myself, but so there are two conditions that I'm thinking about. First condition is if there are just no any zeros. I added 0 myself at the end here because I do not want to because I also wanted to look at last. I mean, I also wanted to maybe what if I do not add any 0? If I do not add any 0, then also there will be 2 zeros here, and then 1 1 2 0 and 3 1s. Maybe I should look outside for a little while. So I'm talking about edge case here. There is 1 1 and 2 zeros, and there are 3 1s. So at this case, so for this case it will not work. See, so there is 1 1, right? Current length will be 1, and then there are 2 1s, so zeroth length will be equal to 2, and then past plus current will be equal to 1 because past will be 0 in the beginning, so 1 plus 0 it will be 1, so maximum will be equal to 1 at this point, and since there are 2 zeros, so past will be equal to 0, and there are 3 1s, First will be equal to 0 and current will be equal to 0, zero length will be 0. So again here there will be 3 1s and zero length will be still be 0. So I think what I can do is, if zero length is greater than 0 or I is equal to norm slot length, right? Or when when 0 is stop length, or I get to the end. This way I don't even need to put 0 at last. Okay, this is fine, but what about this case? So I should also consider for this case. Before that I will consider for this case. So let's see. So for this one, I is equal to 0 and there will be 2 and this will be greater than 0. So maximum will be current plus past, and 0 that length is not less than 1. So that's fine, but okay, this case will work. But what about this case where there is no any 0? How will I know? Suppose if there is no any zeros, then there's just 1 2 3 4. Then one, two, three, four. If I is not equal to norm start length, if I'm not reached the end, then I need to reset this, right? Otherwise I don't even need to reset it. So what I should do is, if 0 dot length, oh no, I think even 0 dot length will always be, even in this case also, right? So 1 1 1, 0 length will be 0 only. So actually this will not work. I think what I can do is, I can just set an encounter let 0 found is equal to false. I can just say if it is 0, then 0 found will be equal to true. So 0 found is equal to true. If this is true, then max, otherwise max minus 1. I think this should work. I am already past 44 minutes. Great. I solved, I mean it is accepted my first sort. So this is, all this time is worth it. Okay, thank you so much for watching, guys. Bye.